Okay, good morning. Welcome to
Fun math number 140.
Fun Math number 140. Today we found a really neat problem on an old American Junior High School mathematics exam from 1990, I think. And it was a problem about a cube. So we spent a little bit of time talking about it. I thought we'd make another problem like that and see how this goes. The numbers on the face of this cube are consecutive integers. So it's like a die that you roll.
Yeah.
Right? But it's not 1 through 6, it's something else. The sums of the two numbers on opposite faces are equal. What number is opposite of the number 7? I suppose it's good to finish the question, right? What number is opposite the number 7? So I've got this cube. It's got consecutive integers on it. The sums of the two numbers on opposite faces are equal. What number is opposite the number 7? Okay, so it's a little bit different question than what they asked in the test, but I think you can think about this. Okay, so how do you want to approach this?
Well, some numbers have to be, there's going to be 8 and 9 on for two of the other numbers.
Okay, why is that?
Because we need 8 and 9, so 7, 10, and 11 are consecutive.
Okay, so in order for it to be consecutive, we have to have 7, 8, 9, 10, and 11. Okay?
Yeah. So there's two choices. We can do 6, 8, and 9.
Okay, which would mean the numbers on the cube are what?
6, 7, 8, 9, 10, and 11.
Okay, since we need an 8 and 9, we could have the other missing three numbers could be 6, 8, and 9. Or they could be?
Or they can be 8, 9, and 12.
Or they could be 8, 9, and 12. Okay, great. So our numbers could either be, we have case 1, the numbers are 6, 7, 8, 9, 10, and 11. Or the numbers are 7, 8, 9, 10, 11, and 12. Those are our two cases, right?
Yeah.
Okay, so how are we going to figure out which case it is?
Well, it also says that the sums of the two numbers on opposite faces are equal.
Okay.
Let's test this case first.
Alright, let's test case 1 first.
So, let's give the smallest number the largest missing one. So that gives us a 16.
Alright, what do you mean? What numbers are you pairing together here?
I'm putting a 7 and 9 together. So this one and these two are paired.
Okay, why did you decide that?
Well, actually, either way, it's not going to work.
Why is that?
Because even if you give the largest one the smallest pair, 11 and 6, it's going to be 17, and you can't make a number 17.
Okay, so here let's step back from this a second. The way to make these sums equal, there's only one way to do it. You have to pair the smallest with the largest, the next smallest with the next one, and then like that, because this all adds up to 17, right?
Yeah.
Okay, so 6 and 11, 7 and 10, 8 and 9. Can you do that on this cube and make those the opposite faces?
No.
Why not?
Because 7,
What's wrong?
8 and 9 are missing faces.
8 and 9 are missing faces, that's true.
So that means you can't have them opposite each other.
That means they can't be opposite each other. Which other pair cannot be opposite each other?
7 and 10.
Why not?
'Cause
Because they're right there. Okay, awesome. All right, so what about case 2 then?
Case 2, we can do the pairing trick.
Okay,
We get 19 every time.
all right, now
And
does it work?
Yeah, it does.
Okay, I can put the 12 opposite the 7. I can put the 9 opposite the 10, and I can put the 8 opposite the 11. Okay, so what number is opposite the 7?
12.
12. Okay, very good. High five. This is a tricky problem. You got to think a little bit of three-dimensional geometry on the cube. You got to think about how you pair the numbers together to make the sums the same. Pair the smallest with the largest, and then zoom like that. Okay. Good job, sweetie. Good job. This is a tough problem. This is a problem for junior high school kids. So it's definitely tricky.